Hi there, my name is Jay with Server Matter, and the purpose of this video is to teach you how to create in Proxmox a ZFS root installation. We're going to use it on a Raid-z2 environment, which means it allows for a 2-drive failure. We're going to have 6 virtual drives in our exercise. The idea that all of these virtual drives are in fact living on the same physical drive, which is actually a ZFS array in itself within Proxmox, really doesn't concern us, because one of the main features that we're looking for here is the going back in time when we need to on any pool within that ZFS environment. And who knows, it could be that there's some advantage to being split up into a series of virtual drives instead of one logical segment of the drive. I have no idea, but we use that particular drive strategy in a lot of our physical servers, so it made good sense to us to be able to do it on the virtual environment as well. We have some VMs where we're using 6 physical drives but using a virtual environment and pass-through. That's always a possibility. In this case, we're using virtual drives. We will also be using a backup drive. Currently, we're using the backup as a virtual, but we will convert that to a physical at some point to get real backup protection on that. As part of this video, we're going to include a free script. Now, this script we actually found elsewhere, and we're going to give credit to that in the description. And we have heavily edited that script so that it could handle not just the mirror root, but the Raid-z environments as well, along with a few other things like hard coding in options and whatnot. So, but big thanks to the creator of this script, and we hope it will be of value to you as well as it has been to us. And without further ado, let's get on with it. All right, to start with, make sure you have your ISO to install Ubuntu server. Proxmox comes with a place here in local server 1. I have ISO images, and then there we can upload a file or download from a URL, and they get placed there for use in any of your VMs. It's a central repository. We have created a new VM, which we call aimatter.dev. We're going to use it for that kind of testing environment. And this is how it starts off. The first thing you need to do is change your BIOS. BIOS has to be UEFI for Ubuntu 2204. And we'll click OK to that. Next thing, we'll go to our CD-ROM. We will change that to use the ISO from the local environment, and that is that one right there. And now we add our disks. We're going to add 6 drives for the array. We'll leave the default SCSI. I've researched that. It appears to be the fastest of the virtual bunch and with the most flexibility. And we'll go ahead and make, in our case, we're going to make each one of these 6 drives 500 gigabytes. Everything else stays on default. I'm not sure what the benefit of SSD emulation is. You can look into that. And I think that can be changed later if you want to. Yeah, you can. So there's one. Repeat this same thing for all the others. Okay, we have our 6 drives we're going to use for ZFS, numbered 0 through 5, a 0-based array. And we're going to add another virtual hard drive that we're going to use for our backup. Now, this should be converted to a physical drive so that it is truly a backup that's on a different media, but just for the testing purposes and demonstration, I want to show you how that works as part of it. We'll make that one 1,000 gigabytes or a terabyte. Okay, and next thing we want to do is go to our boot environment, which is under options. We want to make sure the boot order specifies that Ubuntu install CD as the number 1. And let's go ahead and click Start, kick it into gear, and take a look at the console. We'll make that full screen. We can see it's headed in the right direction. We'll try our install. Okay, that should get you here. And I want you to be careful about pressing enter too quickly, because one of these screens we have to hold you up and stop progress. So we'll hit enter on the language or select your language, continue without updating, done. The base installation will be the default Ubuntu server. We'll give it just a second to get an IP address, which it has gotten. A proxy address we'll leave blank. And here is where you're going to stop. Right now it's looking for a mirror location, which is the US Archive Ubuntu. It confirms that the mirror location passed test. I still want you to stop, because at this point we need to go to a command line. And the way we do that is different depending on your particular keyboard. But alternate F2 is the norm. Some laptops require you to do the function key in alternate F2. I have even seen control key alternate F2 required. In our case, it's just simply alternate F2, which is the norm. And that takes you out of the installation environment and drops you to a command line, which we need because we don't want to install Ubuntu server on on one of these drives. We want to install it on a RAID array, and that RAID hasn't been created yet, the ZFS RAID, and we're going to do that with our script. So to start off with, we're going to just go ahead and get to a root user by typing sudo bash. We will cd space / / to get us to a root directory. Okay, let's talk about the script itself. We're at a command line. At this point, we need to run the script. Before you can run the script, you've got to get the script into your installer environment. Well, it doesn't come on the media, so it has to be gotten externally. You can attach a USB device, mount it, and get it that way. In our case, we're using SCP. We've got the script on one of our other servers here in the store, and we'll bring it in that way. It's going to ask you, if you're using SCP, if you want to continue connecting. Using this key, we'll say yes, provide a password to that particular server, and the file gets downloaded. And there it is. So let's go ahead and run that file. Now, I know you don't have to use sudo when you are a root user, but I'm just not sure that there isn't something within the script that might carry it forward. It probably has nothing to do with it, but I'm going to place it in there for insurance anyway. It asked me if I would like to run the entire script. I'll say yes. This screen is just for informational purposes. Lets you know what it's about to do. And click OK when you're ready. It's doing some updates right now. And here's a list of the drives that it found on your system that you can choose from for your Raid-z2 environment. In our case, we are going to choose zero through 5, which should be, in fact, I better check on that. Hard drives 0 through 5 should be our 500 gigs. You know, one of the things that I recommend that I didn't follow my own advice here, which is on the backup drive, you should probably make it a different, instead of on the backup drive, instead of leaving it as a default SCSI, change it to SATA. Since you're switching it to a physical drive anyway, it'll allow you to see at a glance in this environment which one you're choosing and make sure you are in fact choosing the right one. But we are going to hope that the last drive is in fact the backup drive and exclude it. Okay. The previous screens, forgive me for not talking through those, gave us a list of drives to select. We just select all the drives that we've previously selected. We choose the type of RAID we wanted, in our case RAID-2. And now we're at the options screen for the boot pool. So there are two pools being created by this script, a boot pool and a root pool. We've already gone through these options and tweaked them to what we think is the best, for at least for our purposes. You're welcome to analyze all of those, and you can change them on the fly if you wish. But we're going to just click OK. The same things for the root pool. We've got a set of options. We've already gone through them, and you can change them if you wish, but we're going to OK. This screen is just informational. It shows you how the root pool is going to break down. We'll click OK. You can see here it is setting up partitions on the individual disks. Each disk that it finds will have 4 partitions created on it. Okay, again, don't press any keys here. Don't move forward. This is a pause. At this point, we need to move back to the installation where we're going to make some selections on those drives based on what's been created here. So it tells you that. Do not go any further. I repeat, do not press OK. It tells you to press, in this case, Control-Alt F1, but on my keyboard it's just Alt F1. So let me do that. There we are. And we will hit the Done button to continue past this screen and tab down to the Custom Storage Layout. Click Done. And now we'll go down to the 4th partition of the first drive. We will edit it. We will change it to ext4. We'll leave it at the root, and we'll click Save. And then we can use the Shift key and the Tab key to go backwards, make this a little easier instead of having to go through all those drives to get to the Done button. Click Done, click Continue, type in our user information, and we'll click Done on that. We'll skip installing Ubuntu Pro. We will install OpenSSH. We will skip installing any snaps. And this will begin the installation. Now, even though it says Install Complete, there is evidently a lot of updates still happening in the background, and I recommend we let that go. And it can take 5 or 10 minutes. And you would think that I told it no updates that this wouldn't happen, but whatever a curtain command in target is, yeah, and downloading and installing security updates. So it's doing it anyway, and just let it ride, and when it's done, we'll proceed. But don't click away from this screen and don't cancel the update. All right, now there's a screen we're looking for. At the bottom, it should say Reboot Now, but do not reboot. Instead, I want you to hold down your alternate key and press the F2 key again. That's going to take you back here. At this point, you can proceed. Just go ahead and proceed. Hit the OK button. Okay, there's the blue line we were hoping for. At this point, it's syncing the operating system install to the partition. And here it says, waiting for file systems to unmount. That's a critical point that most of the time works wonderfully, and you get a screen like this. Now, I want to share this page out of our recorded knowledge. The script completion will take one of 2 possible outcomes: a white dialog screen that says success, which is what we just saw, which is really the one that feels the best, and the next one, which is a black screen with a bunch of export ZFS commands that looks a lot like this. If you see the black screen, no big deal. It's because of a mount being busy. You recall at the end it was saying that it was unmounting something. Occasionally we have seen that get stuck, in which case you just run the command ZFS get mounted yes. Then you want to do an unmount recursive force lazy rpool and whatever it gives you as a result of that command. And then export to detach the pools with this and reboot your computer. Now, if during the reboot process you get the dreaded init frames, you want to run this fix, zpool import, as you see there, and then exit, and it survives a reboot. So there's a couple of possibilities in the event that you don't receive this otherwise perfect outcome. At this point, go ahead and click the OK button, and you can hard shut off your machine. Okay, so we're back. We've shut the machine down, and let's take a look at some of the things we need to do here. One is in the hardware. We need to make sure that your CD-ROM, that you've set it to do not use any media so that it doesn't mistakenly try to reinstall something. The next thing you want to look at is under Options, the boot order. And we're going to run a test here. My experience has been that nothing enabled is all that works. But just for kicks, we're going to select one of these drives. We'll pick this SCSI2, OK it, and hit Start. And it brings us to a grub menu, which is obviously not the desired effect. So let's go ahead and shut that down. Go back to the boot order. And now my experience has been you can pick any one of these and it doesn't matter, it's going to fail. We're gonna pick nothing. We'll just leave. Obviously, it's reset the order to some kind of alphabetical or otherwise. It says no devices selected. The VM will probably not boot, but this has been the only way I have found that it will boot is if you select nothing, click OK, and start. And we get what we hope for. We can move forward with Ubuntu 22.04. We get a lot of nice, beautiful greens. All right, and then we'll go ahead and log in. And that's it. Let's take a look around and see what we've got going on. I'll expand that to full screen. ZFS, actually zpool status to start things off. We see our B pool is made up of the same drives, but different partitions, partition 2, partition 3. We'll look at the ZFS list. When looking at these numbers and you do a ZFS list and you see only 511 gigabytes available on the root drive, the root pool, and 38 on the B pool, you think like, well, where is the rest of the space? Well, partition 4, when this script is completely done, it deletes the contents of partition 4 completely. So there's a lot of space available out there for us to use in different ways. But the goal here is to contain the root pool to roughly, this is what the script does, to roughly 500 gigabytes, because we know it's going to need that to do its thing. But everything over and above that, we want to leave as available space that we can use for creating, say, a data pool in our particular instance. Let's take you inside the script just a little bit here. So you see this export Raid-z R pool size gigabytes, 800 gigs, and a notation that 800 allows for, when you allow for a 2-drive loss via Raid-z, should give you about 500 gigabytes of usable root storage, which it does. So that worked as expected. We thought it would end up with around 500. We end up with 511. I'm going to run a parted command so we can get a look at the partition structures, and you can take a look at some of these drives. You see there is a partition 4 with 383 gigabytes of available space on every single one of these drives. Now the 143, if we multiply that times 6, it gives us our total gigabytes, and then we take away the Raid-z2 equation, we end up with the 511 in our root pool. As we showed earlier, partition 3, looking here at the R pool, we can see it is on partition 3, so that fits nicely with what we expected to see happen there. So now, how do we get access to our 383 times 6 minus the Raid-z2 built-in buffer so that we can use that space for a data pool? Okay, the next thing we need to do is run this command. I'll put this in the description area. This will allow you to very quickly format however many drives you have, their 4th partition, as an ext4 file system. I'll go ahead and run that. Yes. Yes. I've done this once before, that's why it's prompting me for a yes. It's overwriting what's currently there. Okay, and the last drive doesn't have a fourth partition, that's okay. We'll run the lsblk command with the F flag, the -F flag, and that will show us that we now have partition 4 is formatted as an ext4, and if we take away the F flag, it will show us how many gigabytes are dedicated to that partition. Okay, so now we need to create a pool that's based on all those partitions. So the first thing we need to do is get a list of what those partitions are. This command, which is going to be very handy, we'll go in and check the disk by ID and find all the partition 4's information. And here we have our nomenclature for each drive. And the only difference is the number 0, 1, 2, 3, 4, 5. And of course the ABC. This indicates where it points to in the dev system. Okay, now that we're armed with that information, we're ready to run our zpool create command. Now that's an awful lot to digest, and I suggest you research zpool create to understand better what a lot of these values, these options in here. You remember when we created the root pool, we had some options that we standardized in that area. We've done the same here, so you don't have to modify them, or you can dig into these and look those up on your own and change them as you see fit. One of the things that are going to be important to note is right here. This is where I've named my data pool. I can name it anything I want, but just like B pools and R pools are commonly named that way, data pools are commonly named this way. The underscore AI matter just helps me define which computer, which server this is for, so that if I ever get into recovery situations and I need to recover data, I don't use data pool over and over and over again and take a chance on ruining the server that I'm using for the recovery effort because they both have the same pool name. Beyond that, we indicate here that it's a Raid-z2. And then we name our partitions that we're going to tie together, which come from the command just above. You can see that's the first one, that's the second one, and so on down the line to the other 5. So a total of 6. And let's go ahead and run that command. And that's what you expect to get, a very quick happening with no feedback and no errors. Now let's take a look at zpool list, which should show our new pool, and it does. And there's our 2+ terabytes of storage that we were looking for that we couldn't find earlier. Now we need to mount that to a directory so we can actually use it. Let's first create a directory off your root directory called all my data. Okay, this command is going to create the data set all my data on data pool, and it's going to mount it to the directory called all my data. Whoop, because it's not data pool as described earlier. That worked. And although it's probably mounted out of the box, we can go ahead and make sure all mounts are mounted by doing the following. Now we can go into all my data and create something and see that it works. And just to proof and verify that in the pool, data pool, AI matter, it has a mount point on the directory that we just added that text file to. And we can see there it is. There's the data set. There's the mount point. So things are working. Wow. This has been a much longer video than I had any idea that it was going to be. I thought it was just going to be a root ZFS, but then I realized, wait a second, I've got to account for all this extra space and what we're supposed to do with it. I'm sure it's going to be helpful for me the next time I go down this road, because it's a very manual process, but if you've got the sequence down like this and you've got the right script, it's quite smooth and the results are very good, because I've been using it now for at least a year, year and a half, and without issues. So if you made it through the end of this video, congratulations. ZFS and partitions and all the things that go with it aren't exactly cliffhangers, but it's good information, and it'll that ability to use ZFS to go back in time puts you a step ahead of the competition. Thanks for watching. Bye-bye.